Well, I'm glad to be here, and so glad that Career Builder and so many are sponsoring and holding this conference. I've had a passion for data science since I was in graduate school. I went to Georgia Tech for my doctorate, and I earned that 20 years ago, and I've had a career in advanced analytics since then. Most of my career has been with SaaS technology. Anyone using that, SaaS? So SaaS, yeah, I'm right. Not the people who stayed this long. But SaaS is great because the license costs were so high, it did create a vibrant contractor market that I took advantage of for so many years. And you know, SaaS is still out there. SaaS is a Microsoft partner in the ISV space. So you know, we're both partners and competitors, and we're competing, you know, now in the deep learning market as much as anything else. So let me get into my presentation here and see if this works. As I press play, and it wants to work. It does work. Great. Okay. That was our Azure survey, and we'll look at that in a second. So here's my objectives for this talk. 4 parts here. One is describe the Microsoft Cognitive Toolkit. Second, comparative evaluation with similar technologies. Third, outline potential applications. And fourth, show some Jupyter Python demos. Just a little bit about myself and what I do for Microsoft. I work in services, so I'm client-facing. We do have data scientists that work on the product. That's our product team. And we do work together. Sometimes we'll work together on a project, as we recently did with an auto sales company, and they use our interaction to have some client-facing time, and then also make sure that the products they're developing have some real-world significance. We have jobs, and if you go on the Microsoft website, you can see what those opportunities are. I work from home, and there are many work from home opportunities that do require some consulting experience in your background. We do have an office in the Alpharetta area. It's getting ready to move. Right now, it's located near Topgolf. It's going to be moving to Avalon, and there are events there that happen occasionally that are free. And most of the data scientists that are on the product team are either working in Seattle or in the Boston area, but those are not the only locations. Okay. Are you seeing the right thing? Okay. Go back to duplicate. It went off of duplicate when I did that. I press play. Okay, how's that now? Yes? Okay, even though the right side's not right. Look at that, right side's not right. All right, the right side's not right. That's how we're gonna go. Let's go forward. Internships too, for graduate and undergraduates. So what is Cognitive Toolkit? So deep learning is a big buzz now. Let me tell you a little bit about Microsoft, what Microsoft's mission is. I have my badge with me, and they told me when I started, and this was last May, most of the last 10 years, I've actually ran my own small consulting business. And I just joined Microsoft in the last year. Mission is to empower every person and every organization on the planet to achieve more. That's the mission for Microsoft. And these days, Microsoft's very open source friendly. Microsoft's now hosting a lot of that workload in the cloud. We do work with a lot of VMs. 30% of the VMs on Microsoft now are running Linux. And we're also hiring a lot of people that do know open source. When I was onboarded, I sat next to someone who had never used Microsoft Azure before, and he was hired because he was a Linux expert. So we do have now a new world looking at open source, and Microsoft makes money based on consumption, Azure consumption. So that's what the use case is. Cognitive Toolkit, as you'll see, that's where Microsoft's making the money on Cognitive Toolkit, is going to be on consumption. So this technology is open source. A lot of things have gone open source. This particular one already is. .NET is now open source completely. And a lot of Microsoft's technology is now on GitHub. The number 2 committer company to GitHub is Facebook. Number 1 committer to GitHub presently is Microsoft. And a lot of our technology is on there. This is open source. It's supported on both Linux and Windows, which is 2 ways you can deploy it. Fully open development framework. It's production ready, and this is expresses nearly arbitrary neural networks by composing simple building blocks into complex computational networks. Yeah, I'm hearing a voice in the corner here. Is it a delay? Okay, I don't know what that is. I got a bot working for me in the corner. I didn't even say, oh, you know what it is? I know what it is. I know what it is. We left the microphone, the voice on here, and there's some audio on the slides. That is what it is. Okay, this is the team here that had a historic speech breakthrough, and they had 5.9% word error rate. This was in a ArcSiv paper. I do have the slides available. You can get them from our organizer if you want to look up some of these papers that I'm going to show. Comparative evaluation. So this first one here is ImageNet. This was in 2015, and the team there that competed, and this was not me, this was other people, got a top 5% error rate. Microsoft had all 5 entries being the first place in 2015 in ImageNet classification based on this technology. That was an earlier iteration of the cognitive toolkit. Now, this benchmark was in September 2016. The LSTM performance 5 to 10 times faster than the other tools benchmark at that time. And for convolution image cast, it's comparable, but note the authors were using 1.7. The 2.0, which is now release candidate, it says beta here, but it's now release candidate, is 30% faster. They're continuing to try to speed that up. And the performance is superior to TensorFlow on that study. And this is what is in that particular paper. You can, you might want to study it now. This is just a slide. There's an actual paper that goes into the details of how those tools were benchmarked. Benchmarking is always important. I've had to do that as a consultant over time with different technologies. So I'm always looking at what are, metrics that are fair to compare technologies. These numbers here, you mean the columns here, FCN, LX8, these just represent different tests that were done on the, and the lower numbers are better. This is speed. This is speed. So this is like same task, how fast did it take? So lower numbers are better. And I know somebody put 0.037 here in the first graph. Is that statistically significant at 0.038? Maybe not, but it's faster is faster. So you do have to run your own benchmark tests. The thing is, you see these public benchmark tests. As a consultant, I periodically have to run some benchmarking tests on the client side based on their workloads and on their machines. So this type of information is useful for me and something I might do for a client. So then we have some different technologies here. Figure compares. Now let's see, part of this is covered by my little box here. Frames processed per second of CNTK basic fork toolkits, and uses a fully connected 4-layer neural network. All results retain the same hardware, and these were the software versions from several years ago. The software now is changing so fast, like this graph is like out of date, right? Because everything's changing. So it's just an idea of the type of things that people are doing to compare speeds. Let's talk about some applications. So one place it's used now is in Cognitive Services API. In my regular work, that will be the #1 place that deep learning would show on a project. And some of those APIs have to do with vision and speech recognition. We've had several clients contact us about the vision API, and they've had actually very similar requests. People are taking pictures of the outside of buildings looking for maintenance issues. And they use drones, and they use humans, and they're already doing that. But what they're asking us is, could we train a vision library of images to be able to go through these, what's thousands of images and be able to detect flaws? Now, the price to pay is you have to start with 5,000 tagged images. And we do have a standard image library. If you showed a picture of a dog or a car, it will be able to identify that. But what we're talking about is a customized database now, because these are images that are not in a public database, and they'd have to already be tagged a certain way. Is there going to be work for doing that? Yes. Is there going to be work for creating more tags in that for all types of use cases? Sure. Howold.net is a public-facing tool that you can see. You can take a picture from your computer and see if it can guess your age. Caption bot, there on the right side. Some clients now are interested in using bots, and I think we are going to see some uptake on that, combining bots with already existing applications. So it's not like they would stand on their own, but they would be a supplement to an application that's already running. You go forward. Uber's using cognitive services to verify the ID of drivers, and that was in September 2016. And then there's some other examples here, refrigerators using CNTK. Okay, I'm going fast through here because I want to show some stuff from the web. So there's all this information for Cognitive Toolkit is on GitHub. It's open source. So again, you can just download it. You don't even have to log into GitHub. You could. Yes, log in and become a contributor. But what I want to show now is, let me show some of the information. This is why I wanted to have my computer, so I could show some of the information here about Cognitive Toolkit. All right, the main website, Cognitive Toolkit, is on the Microsoft website, and it describes here what some of the features are, how it works, and then there's some model gallery. It's a model gallery here with 48 different code samples. Now, I have not personally used TensorFlow. I know that there's so many training courses out there on TensorFlow and easy ways to get started. Microsoft, as I understand, doesn't have as much corpus of material, but there is much material, and it's here. And I'm going to show some of it today. Let's look at some of the features here. Components can handle multi-dimensional, dense, or sparse data from Python, C++, or Brain script. And then you see all the different types of neural networks that it can do, and then reinforcement learning, and then GPUs. And I'm going to show GPU in a second. One of the GPUs is running a virtual machine that you can provision from Azure. 10 minutes. One thing that recently happened is Microsoft updated the product. This blog post is from April 3rd, and so now the version 2 is now release candidate. So it goes from beta, the release candidate, to general release. Release candidate means pretty close to being production ready, and then it's going to go full scale. So this particular version supports Python 2.7, 3.4, 3.5, C++, and C#. The Jupyter notebooks that are set up as tutorials for this are in Python, and the ones that are come provisioned with the VM are Python 3.4. I do know it works with TensorBoard. I didn't see where the list is, but I know I saw it and I couldn't find it again. I'm just going to mention that. And then there's also these Docker images. So you can get the CNTK available as a Docker image in Docker Hub. There's a lot of people interested in Docker now in organizations, especially because there's so many use cases where a container does make sense. That's just one thing that's available. Okay, and let me go to show some of the Jupyter notebooks. Okay, this is the list of tutorials here, Python API. So I will go to the first one just to be, show one at a time. And for those of you who don't know, Jupyter is a new face on some older technologies. J, Julia, Pi, Python, R. R, 20 years old, Python, 20 years old. Julia, pretty new. I do know companies doing Julia, it's based in Jacksonville, Florida. I don't know if anyone here is working with Julia for any production use. People are already making money on that. So this technology allows for a interactive code to run inside the browser. And what will happen is some point right here, there's a line that says from CNTK import star. That's when you have the CNTK package, and then it starts going to the CNTK. And then it will test here, test your device, whether or not it's going to go down the CPU route or the GPU route. That's what's happening at the very beginning. And then you will go down. Now, I'm not going to explain all the code. I think it's explained in this tutorial if you want to see what this one does. It's embedded also with some images and how the network's set up. As I read these tutorials, they are somewhat set up for people who have not seen machine learning before. So just letting you know that if you've seen machine learning before, they're going to explain some things like what is a neural network, what is logistic regression, what is a link function, and you may not personally need that orientation, but it doesn't hurt to see how other people explain the same thing you already know. Okay, there are some other demos here available on a number of other topics. I'm looking at my time. If you see some of them are, here's a feed-forward network. One here is with MNIST data with recognizing handwritten digits, predicting the stock market, which is a fool's task, IoT device, convolutional network, and LSTMs and word embeddings. These are all Jupyter notebooks. And I think that's a good way to introduce a topic and at least surface a technology and make it available. All right, now let's look at the results from the survey. Nothing. I lost it. You don't have any of these? Lose things. Okay, all these results. Okay, Azure Analysis Service is relatively new. We only got 11 people that answered the survey here. I think, I showed this in Hong Kong and almost everybody had this QR code thing going on. All right, Bing, a lot of you have heard of that. Cortana Intelligence, CNTK is where we are right now. Stream Analytics, so in Azure, you can do batch processing, but you also can do stream. So you get these stream providers, resources that collect from devices. There's two, there's the slow speed and there's the high speed. High speed costs more money. And with Azure Data Factory, which is on here, which nobody's seen before, it's an event gatherer that will take stream events, it can put that into database and then process models at a certain frequency. The use case here is we're thinking about production systems, what someone might want to build. Docker, of course, is important. Linux and R Server, Power BI. The other technology you may have seen is Azure Machine Learning, and that's right here. Azure Machine Learning is the drag and drop interface that works with R and Python. And then Visual Studio, which of course is everybody's favorite Python IDE, right? I know. Okay, so what I did is I provisioned 2 machines, just to show you, and this is the last thing I'm going to show here. I provisioned 2 virtual machines. They happen to be Windows. They didn't have to be Windows, but these ones are Windows. There's also a Linux version. And this one's called the Data Science VM. It already comes pre-built with a lot of things in here. And you see, I can't see on that screen on there, but on the right screen, I can see it. We got Julia's already in there, Jupyter. You see RStudio's there, Power BI Desktop, which is absolutely free, by the way. You don't have to use Explorer, it's Firefox. And then Weka's in here, and a lot of other things are already in here, and including SQL Server. And CNTK's in here too. Now, when I put the CNTK in this particular IDE, I picked Visual Studio, and this one's 3.4, and I ran these 2 lines here. This first line says, connect the device, and the second line was about the GPU. This particular VM does not have a GPU. So when I do the GPU, it gives me a red error, like it says there on the screen. Then I was curious to say, and the other one, we do have one that's called the deep learning So that's the one for this group, right? And even if you don't use this, you can use this image, or you can use your own image, or you can build something like it. Okay, so I'm just saying that, we're not saying this is the only way to do it. This is one's already pre-built, so you just provision it, give your username and password, and there you go, you got a VM. Now the deep learning VM, it's only got one configuration right now. So this one has 56 gigabytes of RAM, and then I found out what the GPU is, and I figured it out half an hour before I started. You go into Device Manager, and you can find it's the NVIDIA Tesla K80. And so I said, what is the NVIDIA Tesla K80? And I lost my page there on that. K80. This is the GPU you get in that VM. I think there's a partnership between Microsoft and NVIDIA. All right, so this one says 4992 NVIDIA CUDA cores with a dual GPU design, 24 GB of GDDR5 memory, up to 2.91 teraflops double precision performance. So that gives you kind of an idea of what that GPU is in that virtual machine. So once you run it, difference here is when I ran the same codes inside Visual Studio, it just took it. So right there, it's set up and it's like ready to go. And it'll run against the GPU inside the machine. A long time ago, I bought a kind of mid-level NVIDIA GPU, and I put it in my home server that runs 24/7 as a social media computer, tweeting and all that stuff. And I had an aspiration of doing GPU experimentation with it. Now it's so old, and I don't even know if I'd want to do it. And now I can just do it against this account. I was also worried about how much this would cost, but I didn't see any VMs that are more than $9 an hour. I know the first one is $480, so I left it running all the time. This one is not as much. VMs are very expensive, and on the cloud, it's the #1 thing that's a budget killer, is a VM. And that's why Microsoft's doing a lot of things as software as a service, so you pay on use. So like the Cognitive Services API, that's paid by use. You pay for what you use. I'm going to pause right there, and we do have some time for anyone who may have some questions. Yeah, I'm going to take up questions. Please.
Thanks for the presentation. I have a three-part question. So this toolkit, is it accessible from the Machine Learning Studio?
Is it accessible from the Machine Learning Studio? The answer would be yes. You would install a package, and I would run it from Python. You're talking about Azure Machine Learning?
Yeah.
Yes. Have I done it? No. Would it be connectable to GPU? Probably not.
So what is the optimal way of accessing this toolkit?
The optimal way of accessing, okay, so it's just a toolkit, so it's just software, and it's open source. So you would want to put it on your best machine. So like, all the other machines aside. And I know maybe a lot of people work in a corporate environment. When I'm usually in a corporate environment, they used to, and not anymore because everything's on the cloud. They used to give people who are in the high user scientist category the best computers. And these days now, because of the VMs being available, that usually seems to be a path to do any type of development, and then shut it down when you're done. Because if you're not using it, it's costing money. Yeah. I have a question for you. Have you done any work with GPUs, or are you interested in doing that?
Yeah, actually, I did some CUDA.
Okay.
Hardcore CUDA programming,
Excellent.
Combination, comparison.
Wow. Okay.
So the VM server you showed us, is that like downloadable, or did you show it from the Azure account? The remote desktop.
Right, the remote desktop. One of these is my personal computer at home, which is the one with the survey results. This deep learning VM, this one is one I spun up from Azure. It's called the deep learning virtual machine. And then the second one is just the data science VM, Windows version. There's another one, it's Linux version. It's from the Azure portal, right?
Thank you.
Mhm.
All right. Perfect. Timing.
Good.
Thank you, Mark, again.